All right, so this lesson is on 3.4. That is, instead of graphing, so yesterday's was graphing, how do we solve it just from the equation itself? Well, you will see that factoring is going to be a huge part of the deal. So again, every time they want you to solve something, typically, they give you, so y equals given, typically, and they want you to find what x is. That's usually the case when they're asking you to solve. Okay, so if you want to put a little note on that, you can. So solve, how about I do it myself? Solve means, okay, y usually given what is x. That's essentially what the question is. So let's get to it. If that's the case, take a look. For question A, the y value is a 0. Yay. What's x? That makes this true. Again, just like yesterday, you can plug in any number you want and test it, and test it, and test it, and that's really annoying. So instead of testing every single number out there on the number line, the best way to do it is factor. You'll see. This is a simple trinomial, so I can go ahead and draw the brackets right away. Something that multiplies to -24 but adds to -2 is going to be a -6 with a +4. And you're half done. So if this is what my previous trinomial is equal to, what x values make the equation a 0? Can you draw from yesterday's lesson or the previous lessons? How do we go from these brackets to these x-intercepts? Yes. Correct, absolutely. So I'm going to go through the entire thing just because it's our first question for today. If x minus 6 happens to be the 0, in other words, if this bracket was the 0 that makes the product a 0, x would have to be a 6, which means when x is a 6, my y value is a 0. Right? If, bless you, if x plus 4 was the bracket that made this entire product a 0, that means x must have been a -4. And so this are my 2 points. Another way I can write this is my final statement. So therefore, when x equals 6, therefore, y is equal to 0 when x equals 6 or -4. That's a better way to write it. And instead of therefore, let's be a little bit lazy about this. Instead of therefore, you can do the 3 dots. 1, 2, 3. So again, number 1, I'm factoring. Sorry, I should write this down. Instead of saying number 1, I make sure that the y value is a 0 so that when I factor, I can use this strategy. That's it. Which means I want to see if I could apply it for all the other questions. Here, I do not have a trinomial. To reach back to your chapter 2, this is still factorable. And remember, it's in the form of, good morning, this. It's a difference of squares. Do you remember how you can factor this right away without even thinking much? Once and twice. All right. By definition, then, I'll do this for you. By definition, A squared minus b squared is actually a product of a and b plus minus. So to follow suit, this is going to be, what times what is a 9? 3, of course. What times what is a 25? 5, of course. You have a plus and a minus in between. So this was a difference of squares. This is what we call a special case. Difference of squares. I think this section is chapter 2.6 from our textbook, if you want to take a look at that to review. You never know if you ever come across this in the future. And so, there's my challenge. Ooh, what values of x makes this bracket a 0? It's not a 5. It's not a negative 5. Let's do this. If 3x plus 5 equals a 0, I'm going to do some algebra, okay? I'm going to subtract both sides by 5 so that the left side is just 3x, but the right side is negative 5. Next, I'll do some algebra again. I want x all alone. So I'll divide both sides by 3, giving me negative 5 over 3. I know that's a decimal. I know. That's okay. It's still a number. Same thing. Let's see if we can reproduce it with this slight change from a positive to a negative. So if the second bracket, 3x minus 5 equals 0, again, the goal is to get x all alone. Find x. So I'm going to add both sides by 5 this time, giving me positive 5. And now let's get x all alone. Divide both sides by 3, and I have 55 over 3. So therefore, if my y value is a 0, I can get this by having my x value as negative 5 over 3 or positive 5 over 3. You will see every single time. We're going to make sure the y value is a 0 and then factor. Y value is a 0, factor. Y value is a 0 and factor. Okay, and this is how you solve. Remember, the whole point was get that x value. What is that x value? We are going to continue with question C, and then we'll jump to E because letter D it's a little funky. That's more of like a T question, I suppose, that I'll do if we have time, but you don't have to concern yourself with that for our assignment. So I'm going to move over. Any questions before we look at C? Some people are still copying, that's fine. For those of you who have copied, take a look at letter C. And before you even try to solve it, tell me what looks different about that versus A and B. Why does that look a little different? What makes it more confusing? Find it. Yep. It's not a 0, so we're stuck. We can't do what we've been doing because it's not a 0. But lucky for us, we can add and subtract. We can change it so that it is 0. So that's going to be our first goal. Remember, even in A and B, we said set it to 0, factor. Set it to 0, factor. For letter C, I would like you to set it to 0 and factor. I'm going to clear here. So how about I zoom in a little bit so I have a little bit of space. Okay, let's set this to 0. This is going to be 4x squared plus 20x plus 25 equals a 0. If you're wondering why, remember, I want one side to equal a 0, so I chose a negative 25. I added 25 to both sides. If I do that, this portion becomes a 0, and then the left side just gets an additional 25 to add. Right? Now I have to factor, which is annoying because this is not a simple trinomial. It has a number here, so it's a complex trinomial. Let's do it. A times C is 100 and B is 20. I need two numbers that multiplies to 100, but the same two numbers will add to 20. I think you'll find it. It's pretty straightforward. Yep. Yeah, 10 and 10. So let's do it. Decomposition, unfortunately, because of that 4, we have to do it the long way. This is 4x squared, 10 and 10. Okay, and if you can't quite remember where this came from, I believe it's 2.4 or 2.5 from your chapter 2. I think it's 2.4 or 5. Forgive me for not remembering. Okay. Next, we will group two terms, group the other two terms. And we will common factor the two terms and common factor the two terms. So 4 and 10, I think I could divide out a 2. X squared and x, I think I could divide out a x. This becomes 2x plus 5. And if you're not quite sure, just go backwards. Try multiplying this back in using distributive property and see if you get the previous line. Like, see if you get where you came from, right? Just to make sure. Next, 10 and 25, I think I can factor out a 5. This becomes 2x plus 5. And I know I'm doing it right because the two brackets that I have left over are the same. I know I'm doing it right. So I'll finish this off by common factoring. If I common factor the 2x plus 5 bracket out, I'm left with 2x and another 5. Hey, would you look at that? They are identical. Woo. I think we spent like 2 classes just doing that in class in chapter 2. So coming back, why do we spend so much time learning factoring in chapter 2? It all comes back to this. Okay. Last step. Now that we factor, we just can solve. Yes. Yep. Where did we get? Oh, sure. 100. If as a refresher, is the product of the first and last number. So that was the trick as part of decomposition. The A value is a 4. A value is a 4. The C value in this case is positive 25. It is A times C. So that was the extra little trick. So here, because both brackets are exactly the same, I'm only going to do this once. If the bracket 2x plus 5 happened to be a 0, that means 2x would be -5. And that means x would be -5 divided by 2. Therefore, x equals -5 over 2. The bottom line, it's, hey, 4x squared plus 20x equals -25. Hey, I can make that happen if x equals -5 over 2. That's it. We've got two things to do. I am going to get us to work through E, and you'll see that letter E is actually the same as the question on the back. Right? I just wanted to throw it as a math question versus an application. Last minute questions. So in this case, instead of telling you what to do, it's going to sort of ask you for a variety of information. Move to last. Second. Very last one. Quick typo. That's not a D, that's just a regular X. The D for distance is actually in the back question, so that's just a mix. Okay, here we go. Solve when this function equals 0. Look familiar? It's exactly what we did before. So little I, can you solve when this is like that? And of course, we need to factor, right? Set one side to 0 and then factor. If you're wondering why this is not a trinomial and why it might look hard, here, how about I help you out? The third number is a 0. So you can do it as, what are two numbers that multiply to these two, or but add to 2? I know it's a little bit weird, but I don't think you even have to do that. Yes. Pardon me? Other x as a 0? Oh, well, because it says solve when the function is equal to 0. So yeah, the question is asking, if that entire equation does equal a 0, what would you do? Well, this is something I notice. I notice that I can actually factor out a -0.2 first. So I'm going to divide -0.2, divide a -0.2. You can do that in the calculator, but I'll do that for you. This becomes -10. But I show you, oh, no, not calendar. I don't want a calendar. I want calculator. Calculator, let's see. 2 divided by 0.2 negative is equal to -10. Okay, so you can do that on the calculator, no problem. Let's get this out of the way. Next, let's actually go further. I see an x squared and an x. I'm going to common factor further, giving me there. And if that equation is going to equal to 0, then that bracket must be equal to 0. And this bracket must equal to 0. So what are my x-intercepts? What are the values when y equals 0? Yep. Close. This one is just a 0. That's correct. If x equals 0, then x equals 0. But here, if x minus 10 equals 0, 10 must be positive. To determine the x-intercepts, well, I found them. The x-intercepts are 0, 0, because when x equals 0, my y value equals 0. Right? Or I'll do it up here. My y value equals 0. If x equals 10, my y value also equals 0. Okay, so let's visualize, if you will. I have a 0 and a 10, sort of like our Desmos assignment. What's my axis of symmetry? Right? I go up, I go down, 0, 10. What's my axis of symmetry? Maybe not calculated, but where is it in terms of 0 and 10? Right in the middle. You're right. So if you recall, the axis of symmetry, logically speaking, is perfectly in between my 0 and 10. So if this is a 0 and that's my 10, it's going to be perfectly in between. So axis of symmetry, x, is going to be an average of the two x-intercepts, which looks like this. 0, the 10, perfectly in between is an average. That would be 10 divided by 2, that is a 5. So okay, we got it. It's a 5. Yep. So the equation for the axis of symmetry is just x equals 5. Yes. If you can calculate it straight off the bat, that's fine. But because you'll be using real life data, you might be getting something like 0 and 73 centimeters. You know what I mean? So yeah, always be prepared. And then part 4, let's continue. Okay, now that I know this is a 5, how high does it go? What is the point of that vertex? Anyone remember how to calculate this? You know one of them is going to, like the point is going to be a 5, but what's the y value? Going once, going twice. Well, look, isn't that the y value? Plug in the 5. If x equals 5, what does it spit out? So let's calculate it. Okay, let's do it. What is the y value when x equals 5? Negative 0.2, 5 squared plus 2 times 5, which is, you're going to need a calculator. Mm, 2.5 negative 5 plus 5. I guess I'll be your calculator. It's a 5. How do I know this is the vertex? Once again, my x value of a 5, I know is perfectly in the middle. And so it has to be where the vertex is. And when the vertex is, when it's plugged in, I get a 5 as well. So the vertex is 5, 5. Yeah. And one of the last skills you need for this assignment, determine the y-intercept. So before I do that, I need to clear some space. So are there any questions for these four first? Take your time with it, think about it. If you want to ask later, take a highlighter. Maybe you want to like circle this part saying, what the heck? You know, you could do stuff like that. Yes. For this part? For number 4? Or everything? Just this part, sure. Would you like me to write out the logic behind it as well? Just the steps. Okay, so part 3, okay. Axis of sim is x equals 5. Okay, great. Yeah, sorry. 4. So the axis symmetry is x equals 5. Plug in x equals 5 into equation. Right? When you do, you will get y value when x equals 5. In other words, aka find the point 5 comma y. Okay, so once you find the axis of symmetry, which was x equals 5, plug in that 5, and it just so happens, coincidentally, the y value was also 5, but it's not always the case. Last bit, particularly for your assignment, that will help. Determine the y-intercept. If you recall in one of my lessons, y-intercept automatically means that the x value is a 0. Right? Graphically speaking, if I'm talking about like this, that is my y-intercept. It's cutting through my y-axis. So the x value is always a 0. So what is the value when x is 0? You could probably guess because we already identified what that point is. 0.2 times 0 squared plus 2 times 0. That's 0 plus 0. The y-intercept is 0. It just happens to be the same as the x-intercept. So the y-intercept is 0, 0. It's also an x-intercept, but it's also a y-intercept. Yes. Okay. So the final thing I'm going to do for you, and so today is we're going to keep the lesson really short, right? So you can try to review. On the back of this sheet is the exact same equation, but I'm adding an extra little sentence to try to get you to think a little bit more about it. All right. And so while some people are copying this, I'm going to read the next example. This equation right here, f of x is equal to negative 0.2x squared plus 2x, I wrote it instead as a path of a dolphin that jumps above the ocean surface. The height, h, is the height above the water. The d is the distance above, from the point where the dolphin breaks the surface to the point where they fall in, both in feet. When will the dolphin reach a height of 1.8? Take a look. So because this is the same equation, let me try to do a quick visual for you. The visual is not always going to be available, but this time it is. So this is my water. You get the point, okay? And here's the sun, and here are nice clouds. Oh, it's little gray clouds, but you get the point, okay? So I got myself a dolphin. Dolphins have dorsals, right? Okay, and just like before, we know it's gonna break through here, and it's gonna fall. Take a look at your previous example. If I'm jumping from 0, when am I landing? Based on our question? That's where we break the surface. Where are we landing here? What's my x-intercept? 10. That's a really far jump, okay? And also, based on our math, how high does it reach? 5. 5 at the 5-meter mark. Now, 10 meters, that's a big jump. Anyways, whatever. Okay, it's fiction. Relax. The question, though, asks, when will the dolphin reach, so when will the dolphin reach a height of 1.8? Look at this carefully. Read the question carefully. Is the height a d value, or is the height the value on the left side of the equal sign? Think about it. H of d is here, and there's a description. D is there, and there's a description. What am I talking about? What the heck is this? Where does it go? I don't mean to confuse you. I wanted you to think about it though, because it's really good exercise. 1.8 belongs on the left side of the equal sign because that represents the height. D represents the horizontal distance. Okay, the question is now you have to solve, right? When, so what distance will the dolphin reach a height of 1.8 feet? Solve it. That's it. It's so simple. No. But you can't solve it right away. It's not that simple. So how do you solve something like this? What did we do before? Anytime you wanted to solve, you have to set to 0. So let's do it. If I want to set to 0, and the left side has to subtract by 1.8. So both sides are subtracted by 1.8, subtract by 1.8. The left side becomes a 0 because you can cancel this part out. And the right side gets a negative 1.8 because you can't do anything with that. So, oh look, I have a trinomial. Would you look at that? I do not like this negative 0.2. So just like before, I'm going to common factor this out, leaving me d squared, subtraction of 10d, and 1.8, so negative 1.8 divided by negative 0.2. That's going to be 1836. Correct me if I'm wrong. Divided by this is like, well, oh, I could be wrong. 0.8 divided by 0.2 divided by 1/5 is like saying multiplied by 5. That's a 9, isn't it? It's a 9. Just double check that. Yeah, stupid me. Okay, so here I have the negative 0.2, that's fine. But on the bracket portion, I have a simple trinomial. Yay. Two numbers that multiply to a positive 9, but add to a negative 10. Negative 9 and negative 1. Which means D is going to be a 9 or D is going to be a positive 1. What does that mean? That's weird. That's totally different from our answer before. Well, that makes sense. If you want my Y value to be 1.8, it has to be a 9. If I want my Y value to be a 1.8, D is going to be 1. Why does that make sense? Think about it this way. Remember, the height of 1.8 is around here. Which means I'm going to reach that height at 1 second, or I will reach that height at 9 seconds. So the math works out too. But remember, you always have to set it to 0 if you want to find those answers too. A height of 1.8 is going to be reached at 1 second or 9 seconds. Or am I saying? Not seconds, we're talking about distance. It'll reach a height of 1.8 feet when I jump horizontally by either 1 foot or 9 feet. Sorry about that. I keep thinking about it as time because of the word when. Okay. You will see lots of questions like this where the words will give you a trinomial or a quadratic, and you have to factor to solve for numbers that work. Okay. All the questions in the homework section, number 8, 9, 10, 11, 12, 13, 14, they are all, if you take a look, every single one of those questions give you a quadratic equation and then ask you to either solve for the X value and they give you the Y, or they solve for the Y value and they give you the X. Always going to be a very repetitive thing. So I hope that you'll give yourself a chance. The rest of class is basically homework time. I would ask that you try one question from the left column of the homework and one question from the right column from the homework before you go today. Question? Yes, absolutely. You too, yes? Sorry, say again? The 1 and the 9? Oh, sure, absolutely. Let's look at that one more time slowly. Okay, so I'm going to erase this. Can I erase the picture? Yeah. Okay. As an example, let's do the first part. -2, let's say x squared plus 2x. If I want to factor out a -0.2, I'm essentially dividing everything out by -0.2. Do you see where the arrows mean? Like, do you see what I'm trying to do? Okay, so let's take this one step at a time. 0.12 divided by -0.2 divided by -0.2 is going to be 1. It's the same number. That's why I get 1x squared. Next, 2 divided by -0.2, it turns into a -10. And so I have -10x. Here's my proof. If I take my -0.2 and I multiply it back in, I should get where I came from. So if you take -0.2, multiply that by 1, I get this. -0.2 times a -10, I get a +2. So they are sort of reverse of each other, as you can see from the arrows as well. The same with this one. I did this here, right? -0.2 divided by -0.2 is a 1. 2 divided by -0.2 is a -10. And -1.8 divided by -0.2, I did it on the calculator. It happened to be a +9. Correct. So I divided, so out of all of these, I divided a negative 0.2 out, leaving me 1, negative 10, and okay. All right, I'll pause this video here. Hope the lesson was a lot clearer than yesterday. I'm still beating myself up over that. Handouts are all fixed, and I do have time today, so I'm planning on recreating that video from yesterday's class so that you have better use for it. The answer key though should already be up, and I'm going to include an answer key for this up online as well. Okay. Any last minute questions before I stop? Okay,